Okay, now what am I getting at here? Wait. What am I getting at here? Well, basically, I'm trying to illustrate these methods. In other words, I'm trying to illustrate why what these, getting ahead of myself. In general, if we have an algebraic expression, W, so W is any algebraic expression in X. You know, it could be just X alone, as in these slides, or it could be something else involving X. Now, if you want to solve this equation, what I was trying to illustrate just before, was why we solve it this way. Why we get two equations to solve. So to solve this equation, we have to solve this equation and this equation. And by what I did just before, that illustrates why we do that. Here, for this inequality, to solve this, you want to solve this compound inequality. And why is that? Well, it's really just by what I did before. You know, the way I solved this here, the idea behind it. That's why you solve it by solving this compound inequality. So to solve this inequality, we solve this inequality here. And likewise for this one, we solve this compound inequality. So what I did before illustrates the idea as to why we do this. You know, why we solve this equation this way, by solving these two. Why do we solve this inequality? By solving this compound inequality. And same thing here. What questions do you have so far? If you don't have any, that's fine, but what questions do you have? Okay, well, let's do some examples then. We have the absolute value of 4x plus 9 equal to 3, right? Okay, so from here, what we want to do, right, using the first idea, using this, we solve this equation and this equation, this and this. So we have to solve this equation when it's equal to 3 and when it's equal to negative 3. That's what we have to do, right? That's what this is saying. If you want the absolute value of something equal to b, what you have to do instead is you solve this equation when it's b, and you also solve the equation when it's negative b. So we solve this equation when it's equal to 3, and we also solve when it's equal to negative 3. I mean, we solve them separately. Okay, so for the first equation, what do? We get x all alone. We have 4x plus 9 is 3. How do we get x? Subtract 9, right? We want to get x all alone. So we want to get the 9 out of there. Well, let's subtract 9 from both sides. Right? We want to get 9 out of there. Whatever you do to one side, you do to the other. So we have 4x equals negative 6, as you can see. So from there, we get 4x equals negative 6, like so. Right? But we don't want 4x, we want x. So what do? Divide. We divide both sides by 4. See? Right? Because then we get x all alone, and we get this. Negative 6 over 4, which is negative 3 over 2. Right? So that's what we do. So again, we don't want 4x plus 9. We want x all alone. So we get the 9 out of there. What do? Subtract 9 from both sides. Yeah, what you do to one side, you do to the other. So we have 4x all alone on the left. We have 4x equals -6. And now what do we do next? From 4x, we divide both sides by 4. Doing that, we divide, we get x equals -3/2. Now, are we done? No, we're not done yet. We have to handle this equation as well. We handled when it's equal to 3. Now we have to take care of when it's equal to -3. And that's what I'm doing here. It's actually the same steps as we solved this equation. Okay? So from here, what do? Well, we have -9. We subtract that from both sides. Okay, right? Again, we want to get x all alone, so we want to get the 9 out of there. Well, whatever you do to one side, you do to the other. You have 4x equals -12. What's next? You divide both sides by 4. Okay, we divide by 4. Once we do that, we're going to get x on the left. But remember, what you do to one side, you do to the other, so we divide this by 4. And we get -12/4, which is -3. And so altogether, we get x equals -3. So again, there are two solutions here, right? One from each equation. We get -3/2, and we get -3. This solution set, these two solutions only, you really can't graph them because there's only two numbers. So you could just list them. What questions do you have about this? Okay, let's move on then. Here's an inequality. So let's say we want to solve this inequality. Well, what do? You have to solve this corresponding inequality. Less than or equal to 1, that becomes -1. Less than or equal to this, less than or equal to 1. So you solve this inequality, but you also have to handle this as well. In other words, you have this compound inequality to solve. Okay, so how do we solve this? We want x to be all alone in the middle, okay? We want x all alone in the middle. That's all we want. So here's pretty easy, right? We have x -2. How do we get the 2 out of there? Well, we can add. We add 2 to each side. Once we do that, we get x in the middle, right? And again, what you do to one side, you have to do to the other. We added 2 here, so we have to add 2 here and here. We get x less than or equal to 3, greater than or equal to 1. So what's our solution set? This thing. One less than or equal to x less than or equal to 3. Okay, and that's the same as this closed interval, right? That's the solution set for this. And how do we graph it? You want to put a closed circle over 1 and over 3, and then you draw a line like this between them, right? You're indicating all the numbers between 1 and 3. So that's our solution set. Good. Right, so we solve this compound inequality, getting x all alone in the middle. We get this. Now we're done, right? This gives us the solution set here. And so we have this. Okay, let me do one more. But before I do that, are there any questions? Okay, here's another one. So again, it's just like the previous one, right? We have this inequality to solve. From here, we're going to get a compound inequality. And so from negative 2x plus 3, right? We have this is less than or equal to 5, greater than or equal to negative 5. Right? We had the absolute value less than or equal to 5. So we have this here, less than or equal to 5, and greater than or equal to negative 5. So from here, we're going to get negative 2x plus 3. All right, that's less than or equal to 5. And it's greater than or equal to negative 5. We have this compound inequality to solve, right? And it's just like before, we have to get x all alone in the middle. Okay, what do? Plus 3, right? Well, let's get the 3 out of there by subtracting. But again, whatever you do to one side, you have to do to the others. So we get negative 2x here. That's less than or equal to 2. 5 minus 3 is 2. This 3 is gone. Negative 5 minus 3 is negative 8. So we have this compound inequality. Then we want to get x all alone. Well, we have to get the negative 2 out of there, right? How do we do that? Divide. So we divide everything by negative 2. And you can see that when we do that, well, we divide each side by negative 2. But when you do that, though, right, what happens? Well, you get x all alone, right, in the middle. Here we get net 2 over negative 2, that's negative 1. Negative 8 over negative 2 we get is 4. But again, what happened to the inequality symbol? We turn it around, right? You have to turn it around. And again, that's because you're dividing by a negative. If you're dividing or multiplying by a negative, you have to turn the inequality symbol around. You have to. Right. So we end up with this compound, well, this compound 4 greater than or equal to x greater than or equal to negative 1, which is really the same as this. And so from here, we're going to get this closed bounded interval. Well, this closed interval, excuse me, right? When you have this compound inequality, the solution set we know is this. And so from here, we can graph this, right? You know, you have negative 1 on the number line and a 4, 2 closed circles over each, a closed circle over each one. Then you connect it by a line. Fun stuff. Okay, good. All right. Any questions on this? Because I figured now it'd be good to have everyone work on a worksheet